Hi everyone, my name is Edgaras. I work as a site reliability engineer at Vinted. And today I'm going to talk about how we're using GitOps to deploy our applications to Kubernetes and share the best practices alongside. So first of all, for somebody who doesn't know what is Vinted and what does it do, Vinted is actually a second-hand fashion marketplace, and its goal is to make second-hand actually first choice and increase the sustainability in fashion market worldwide. And I'll give you a brief overview about the Vinted infrastructure, just so you would know at what scale we're actually using GitOps. So first of all, almost all of our services are running in production on Kubernetes, with the exclusion of databases and some stateful applications. So basically in Kubernetes, we're running only stateless apps. Using GitOps, we're deploying more than 2,000, we do have more than 2,000 deployments per day. So as you can see, this graph here shows actually deployment counts from the previous Monday. And in production clusters, we have running more than 6,000 pods, and those 6,000 pods are running on more than 300 physical machines. So that accumulates for around 30,000 CPU cores and 100 terabytes of memory. And as you can guess it, we're running on premises in our co-located data centers, because at certain scale, clouds are actually too expensive. Right, so GitOps. So what is GitOps actually? So I'll tell you what is GitOps and what actually GitOps benefits does it provide. Right, so everybody probably knows Kubernetes, the open source most popular container orchestrator out there. Kubernetes helps us to solve how to scale infrastructure and application headaches. But actually, at some point with Kubernetes, there becomes another problem. How do we actually deploy applications to Kubernetes, right? So in 2017, August, so Weaveworks actually coined term GitOps that actually tackled that problem. They released a software as a service tool called Flex, which actually incorporated this so-called GitOps. So GitOps is actually a DevOps process that provides best practices of deployment, monitoring, and management of containerized applications. And GitOps provides experience for managing applications with fully automated workflows or pipelines using Git for development and operations. And actually, the best use of the Git is when you're using Git revision control system, you can actually track and approve changes to the whole infrastructure. Right, so why GitOps and what benefits does GitOps provide? So first of all, the biggest benefit probably is that GitOps is actually infrastructure as a code. And with infrastructure as a code, you get your state of the infrastructure in version control systems such as Git. And what does actual infrastructure as a code, what benefits provides is repeatability. So it's kind of easier to do over and over same process again. And if something goes wrong, it's easy to roll back, okay? Then there's reliability. When we have automated all of our processes, it's less of human error that something happens. Then it's efficiency. Everyone gets used to infrastructure as a code. So the productivity increases because you only have to make some kind of minor changes instead of using command line interface and running same commands over and over again. And then there's visibility. So with visibility, infrastructure state stored in a code repository actually documents itself how infrastructure should look like. Right? Another GitOps benefit is self-service. So instead for the developers to send a ticket to IT or to DevOps to make some kind of infrastructure changes, developers can work fully individually on their own solution and commit to the infrastructure declarative configuration. And of course, there's code reviews. Besides reducing the error risks, you can actually teach and learn during the code review process. So let's leave it GitOps at that place, and let's come back to Kubernetes, because as I mentioned before, GitOps surfaced when deployments to Kubernetes actually went quite hard. So let's look to Kubernetes deployments, what native ways are to deploy applications to Kubernetes. So basically there's two ways, imperative and declarative. With imperative way, you actually run your commands against some kind of cluster and hope that your application is running down there. With declarative configuration, you have everything stored in manifest, hopefully also in version control system. And you can see all of the changes that being made. You can see all of the history. And you can also check the difference between the cluster where your application is running and what state do you have in your version control system. So when you combine GitOps methodology and Kubernetes declarative manifests of deployments, so you get actually the best practice of how to deploy applications to Kubernetes. And actually GitOps provides best practices of CI and CD workflows. So GitOps actually says that your code and config repository where your application deployment manifests are stored should be stored separately. And the whole CI process should be responsible for the code repository, and the whole CD process should be responsible for your configuration repository. So if we walk through the continuous integration, so usually some kind of system is responsible for continuous integration, like GitHub Actions, GitLab CI, Jenkins, Argo workflows, you name it. So when there are changes into the main branch or pull requests are being raised, so the continuous integration system should build the code, right? Usually it's like building the container image, then some smoke, unit, or integration tests ran, security scans happen. If everything passes, the container image is being signed and pushed to the container registry. Then additionally, another scans of security happen in container registry, signature verification checks, and what happens then is that our CI system actually clones another configuration repository and changes the manifests of our application with the newer container tag and pushes that to the to the upstream. Then another system that's responsible for our continuous deployment, such as Argo CD or previously mentioned Flux, clones tracks the changes. If there are changes, clones the repository, checks which manifests are being changed, and then applies it to the Kubernetes cluster. Now, when talking about the configuration repository where our Kubernetes deployments manifests are being placed, there are two strategies how to deal with monorepo. So the first strategy is single branch and environments per directories. And the second strategy is multiple branches where your environments are throughout branches. So with single branch and multiple directories, it's a common use case and actually the preferred way, because you can easily track in which environments your application is being deployed to. and you can easily promote your applications between the environments. While when you have long-running branches and you want to promote your application to another environment, you might end up in, let's say, this maintenance chaos, right? So that's really not a recommended way of doing GitOps. Right, so we have environments in our Git repo. So, but if you want to, let's say, introduce some kind of changes to our application, and we want those changes to reflect in all of the environments, to copy paste in all of the environments our changes, it's like really inconvenient. So that's why we do also use configuration management. So basically there are three main configuration management tools. First is the Helm. Helm is actually not a configuration management, but a package manager, which actually collects all of the deployment manifests into one binary and versions it. But a lot of people are using actually Helm templating language as a configuration management tool, right? It's kind of okay, but if you have lots of templating, so Go templating language actually lacks the construction, because you might end up with a lot of if and else statements. And with Helm, you can do environments per values files, so I will get back to that later on. Then there's Customize. So Customize was built specifically for declarative applications. So no parameters and templates. It's it gets as close as Kubernetes manifest with Customize, but also the same pattern is kind of limiting with some edge cases. And with Customize, you get environments per overlays, right? So then there's a third tool, which is actually more of a language than a tool. It's JSONet. It's actually JSON on steroids, because you can have comments, you can have templating, and it's not Kubernetes specific, because with JSONet you can also have, you can write Grafana dashboards and so on. But all of these three, JSONet is the least popular, because actually nobody likes JSON. Right, so that was the theory. So I'll show you in practice how at Vinted we're using GitOps. So yeah, so at the center of our GitOps, we're using Argo CD. Argo CD is an open source tool, but what we built here is actually we can build with Flux or any other system. Probably some tweakings are needed, but yeah. So with Argo CD, we're using this so-called app of apps pattern. So with one manifest, we're actually deploying all our applications. So we wrote a custom plugin, which is actually just a simple bash script that goes through our deployment repository, searches for the application YAML files, and if it finds them, it means that this application needs to be installed to deploy it to Kubernetes cluster, and it deploys it. This is how our Kubernetes deployment directory looks like. So at the top level, we have our applications. Each application correlates to Kubernetes namespace. And if we need more applications in the same namespace, we dig a bit deeper. So basically what we have some kind of environment application YAML that you can see example on the right-hand side. Then we have a values file for Helm chart overrides, and if needed, we have common values. Because if you have, let's say, environment variables that are the same for several environments, development, staging, production, and so on, you can just define in common values, and you don't need to repeat these environment variables through all of your files. Right, and our application example, as you can see here, actually in application example, we provide that application which Helm chart it uses, which version of Helm chart it uses, and what values files it uses, right? So for the deployments at Winted, we're using centralized Helm charts. So we actually don't like developers to do everything on their own, so we gave them like a strict cage, so they don't do anything else without our knowledge. So we provide centralized Helm charts, which includes integration with secrets, because you don't store secrets in your GitHub repositories, right? We provide integrations with monitoring, logging, some custom labels automatically are added. And if you want, you can have advanced deployments with sidecars and so on. And everything is stored and documented in our values file. So this is an example of one of our Helm charts. It's like a half of Helm chart. And you can see that we do have a massive centralized Helm charts. And for the developers to use them, they can only override what they want. And they can only override what they want. And for example, so if we go back, so the production application YAML file from the developer's perspective actually ends up like this YAML file. And that's it. And their application is actually deployed in Kubernetes cluster. And this is from Argo CD perspective, how it looks like. But how do we actually deploy new image to the Kubernetes cluster? So in every, we're using Jenkins for the CI stuff. So in every code repository, there's the Jenkins file that does all of the tests, builds, and so on. So if you want to build a container image and change the image tag, you can add just 2 additional stages, build and deploy to Kubernetes. And here we also have centralized Jenkins jobs where developers only pass certain parameters, right? And as you can see here, for example, deploy to Kubernetes is a centralized Jenkins job that it's more advanced, but basically what it does, clones configuration repository, changes the container image tag in manifest, and pushes to the main branch. Right. So as Winted is actually a Ruby on Rails, main application is running on Ruby on Rails. Ruby on Rails, when you're doing deployments, kind of has some dependencies where before the deployment you have to do the database migration schema. And when you're deploying the main application, you have to also deploy sidekicks, which are responsible for the jobs processing. So luckily, Argo CD supports a sync waves, where you can define, let's say, if your image tag has been updated. So before deploying the new application, basically what it does, it looks if it has sync waves and does the order of deployment accordingly. Right, but this actually what it does, it just prolongs the deployments, because if it waits for the other deployments to finish. So that's actually, if you can, you just please avoid the dependencies. Right, so yeah, that was a quick from me, because the networking part is just around the corner. So just to sum up, key takeaways, GitOps is awesome, right? Because from SRE perspective, you get all of the hands-on, and from the developer's perspective, they just write simple stuff and can't interfere with you. Don't use long-running branches in your GitOps repositories. Use directories for environments. Separate code and configuration repositories. Use common values for repetitive tasks. So if you have some kind of environment, as I mentioned before, if you have some kind of environment variables that actually are the same throughout the environments. Just don't copy paste them and just use a common values, and avoid using cross application dependencies. That's all from me.
Thank you, Edgaras. I expect again a lot of questions.
Hi, thank you for your presentation. And a quick question about this approach. How do you roll back?
Yeah, sorry, I did mention before. So we actually have a chatbot where you provide image tag, and chatbot, what it does, it actually calls the centralized Jenkins job to change image version on manifest.
Yeah, but repo is not rolled back, right? So anyone who will commit, who will merge next pull request will deploy roll it back code.
Or you can just do the logs. When you log your application, it actually stops the autosync, and you just force some kind of image to roll out.
Okay.
Right. So actually with GitOps, there's no rollbacks, it's only roll forwards.
Fix things.
Also, I guess that's connected to the rollback part. So how do you promote the changes between environments? Like, for example, you are doing some changes to the Helm charts or some values which are specific for environments, and then you are deploying them, I don't know, to a test environment. How do you promote these changes to another?
Right. So you're asking from developer perspective or from SRE perspective? Because you asked if I'm making changes to Helm charts, right? So actually, if you're making changes to Helm charts, we have here Helm chart versions, right? So we can roll out gradually versions through some applications, and if everything is else, just do the mass change and mass rollout, right? But if from the developer perspective, if he changed something in values files, right? So values files are per environments, so you can easily change values in, let's say, sandbox or staging clusters. Observe it. If everything is okay, then you can do the same changes to, let's say, production environment.
But that sounds like a good part, because it's a change which you do for the first time and then you deploy there to production.
Sorry?
I mean, detach that product.
This seems to be like a weak link here, because like as a developer you have to touch the production values file, and then you have no chance of testing it elsewhere. Like it seems that you can test it on a test environment values file, deploy it to a test environment, verify that it works, but then you have to open the editor and edit production file and deploy it directly to production, basically.
Yeah, that's how it is.
Okay.
I have a question regarding Argo CD versus Flux, like why Argo CD was selected.
Flux is actually only SaaS solution in the cloud, and we wanted to deploy Argo CD, plus Argo CD is open source and it's running on premises.
Thank you for your presentation. I have a question regarding consistency. How you ensure what you have in the Git and what you have in the cluster itself? For example, someone deployed manually. And how you ensure this?
Right, so Argo CD is responsible for that part. Argo CD has auto sync enabled. So Argo CD always observes the Git repository and makes changes to Kubernetes cluster, right?
Actually,
so
it's
if you
deleting, yeah?
If you, let's say, for example, if you delete service, it straight away will be brought back again. If you make some kind of changes in deployment, let's say add additional container arguments, deployment will be again redeployed by Argo.
And if you add some resources, Argo CD will delete?
Yeah. No, if you add some resources and Argo doesn't know about them, right, it doesn't delete them. But there's a option in Argo CD that if it sees that there's additional resources running, it will inform you.
Okay, and about secrets, where you store secrets and how you retrieve them?
Right, so with secrets, surprise, surprise, we're using HashiCorp Vault, right? And we do pass the annotations by default to a Helm chart, in a Helm chart. So basically, init container spins up, adds the secret to the pod, and pod has the secrets.
Okay.
Thank you for the talk. My question is, like, typically in an organization, you have many different types of applications. So it's static front-end applications, like front-end services, back-end services, data pipelines, like whatever. And there are many different types of Helm charts that you would need to implement. How do you approach that? Like, do you consult with the developers, or you just like came up with the basic Helm chart and like, hey, just do something about it? Like, how it works?
Yeah, so actually, when we started the movement to Kubernetes, right? So actually, first of all, we wrote our own Helm charts as we wanted. And then when developers came, they said we need this, that feature. So gradually, that's why we have now like 26th version of Helm charts. So with all of the feature sidecars and so on, and it's like big, massive Helm charts now. And the Go templating language doesn't shine here, actually.
Okay. By the way, your config repo, how many lines of code does it have?
I don't know actually, but we have around 300 applications. So.
Okay. Then how do you solve like number of configurations times number of environments times, I don't know, number of developers issue, especially when each developer has its own env?
Through code owners, actually.
Thank you. Let's have a big round of applause for Edgaras. Thanks for coming. Expect you next year here.